All right, so this lesson is going to be on application problems using right triangle trigonometry. And we're going to be solving real life applications. And so here are the guidelines. So you basically just read through the problem, draw a sketch, find the right triangles, label what you know, and then what you don't know, you want to, or what you're looking for, you want to use a variable. And then we're going to write and solve a trig equation. So it's kind of like what we did in the previous lesson, but you're usually only finding like one thing. You're not finding all the missing things. All right. So surveying is a technique in science of determining the positions or points on the Earth and distances and angles between them. So for this particular problem, I am standing at point A on one side of a river and wish to measure the distance across the river to a house H on the other side. I walk 50 feet along the riverbank to point B, and then I also know that the measure of angle ABH is 18 degrees. So we want to find the distance across the river. So because you can't measure straight across a river, you would have to use a surveying technique. All right, so we can make some little water splashes. All right, so I am here, and across the river, directly across, there's a house H, and I'm going to walk down along the river to point B, and then use my surveying tool to figure out the angle to H. And that is going to make a right triangle. Okay. And then I know I watch 50 feet, so this is 50 feet. This is 18 degrees. And what I want is the distance across the river. Okay, so then I look at what I have, these two sides, or this angle on this side, and what I want, and think about the trig ratio that connects those things. And for this situation, because we're not, the hypotenuse isn't involved at all. And when the hypotenuse is not involved, you're going to use tangent. So the tangent of 18 degrees is equal to the opposite over the adjacent. And then since the variable is up high, you're going to multiply. Right, and then I'm going to label this with the unit of measure. So that would give you a number that many feet. Okay, let's look at the next one. So for example, 6, a guy wire must be attached to a 50-foot pole. The angle that the wire must make with the ground is 75.5 degrees. We're going to find the length of the wire required to do the job. So I know you guys have seen these wires attached to poles to keep them steady, keep them from falling over. Sometimes they're attached at the top. Usually they're not. This particular one is attached to the top of a 50-foot pole, and we know it makes an angle of 75.5 degrees with the ground. And we want to know how long the wire needs to be for this to all work. Okay, so we look at the angle we have, the side we have, and the side we want to find, and that means that we are going to use the sine. And the sine of 75.5 degrees should equal the opposite over the hypotenuse. And then because the variable is down low, you're going to switch, So we're going to switch these two. And this is also going to be in feet. And I'm going to take a second to talk about angles of elevation and depression. So an angle of elevation, as a person at point A looks up at B, an angle of elevation is created with the ground. So if I'm here and you're here and I'm looking up at you, it forms an angle of elevation with the ground. But if you're here and I'm here and you're looking down at me, then it forms an angle of depression with the horizontal. And these two angles are always congruent. So the angle of depression that you form looking down at me is the same as the angle of elevation. Do you guys remember why? It's from geometry. It's something most people really do tend to remember. Is because we have two parallel lines. The horizontals are parallel. This is a transversal. And so those are alternate interior angles, and they will always be congruent. All right. All right. Oh, and one thing that is super, super important, I made it bold and I also underlined things. Angles of elevation and depression are always created with the horizontal. So if you have a situation and a problem where there's an angle of elevation or depression, find the horizontal line, that's where it needs to go. All right, so for example 7, a device for measuring cloud height at night consists of a vertical beam of light that makes a spot on the clouds. That spot is viewed from a point 140 feet along the ground at an angle of elevation of 64 degrees. Find the height of the cloud. So here's my cloud. Don't stand directly under it, you kind of stand at an angle and you point at the cloud and make a spot on the cloud. And you can use that point to find the height. Mm. Gonna be okay. All right. So what I know is that I traveled 140 feet. So this is 140 feet. And then this angle of elevation is going to be 64 degrees. And I know that's the right angle because it's touching a horizontal. It has to be touching a horizontal. All right. Now what we want to find is the height of the cloud. So that is x. And I know when I'm not using the hypotenuse, that is going to be tangent. Tangent of 64 degrees is equal to the opposite over the adjacent. The variable is up high, so you're going to multiply. And this is also in feet. For example 8, while sitting on a cliff 163 feet above the ocean, I see a sailboat in the distance at an angle of depression of 21.2 degrees. What is the horizontal distance to the boat? Okay, so here's my cliff, standing up here, and so here's a sailboat. Didn't make a very straight cliff, but we're going to say that's a right angle. Okay, so my angle of depression is this one, but that is not the angle inside my triangle, but I know because of alternate interior angles, this one is also 21.2 degrees, so I would use this. So if you're in the boat looking up at me, your angle of elevation matches my angle of depression, that is a better angle to use for this situation. And I know this is 163 feet. I want to know the horizontal distance to the boat, so I'm looking for that. This is another situation where we are not using hypotenuse, so it's automatically going to be tangent of 21.2 degrees is equal to the opposite over the adjacent. And in this situation, we are going to switch x and the tangent of 21.2 degrees, and we are using feet again. All right, for example 9, a wire holding up a 40-foot pole is 38 feet long. The wire attaches to the telephone pole 10.5 feet below the top. What is the angle of elevation of the wire? Okay, so here we go. We've got our 40-foot pole. The wire is not at the top, it's part of the way down. So what I know is this is 40 feet. I know this is 10.5 feet. I know the wire is 38 feet long. What I want to know is the angle of elevation. Okay, so I'm also going to need to know the side length of the triangle. And it's not hard. I'm just going to subtract 40 minus 10.5. That is going to be 29.5 feet. Okay, and then, so I want this angle, the one that's with the horizontal, for the angle of elevation. And then I know the opposite, and I know the hypotenuse. So this is going to be the sine of theta is equal to the opposite over the hypotenuse. And so that means that theta, see, we know what the sine is, and we want to find the angle. That's where you do the inverse trig functions. Right? And that will give you theta, the inverse sine of that same fraction. All right, and then number 10. Number 10 is a multi-step problem. So from a window in building A, I observe the top of building B across a 50-foot street at an angle of elevation of 74 degrees. So I'm going to go ahead and draw building B. So I'm at this window and I'm looking up a building B. I know that across the street is 50 feet. And I know my angle of elevation should be touching that horizontal, so that's 74 degrees. Okay, and I'm looking down at the bottom of building B, an angle of depression of 52 degrees. And so I can find the height of building B by finding this distance, we'll call X, finding this distance, we'll call Y, and then adding them together. Since neither one of them are using the hypotenuse, we're going to do tangent. Right, and then the variable is up high, so you're going to multiply. And then for y, the tangent at 52 degrees is going to be the opposite over the adjacent, and then again, the variable is up high, you're going to multiply. Okay. And then to find the total height of building B, we're going to add those two together. That should be the height of building B. All right, so the assignment is going to be on page 6 through 7, numbers 3 through 9.